Okay, so we've got this statement. Let's draw a diagram. Remember I said draw the curve so that it shows you understand, but also helps you. So I'm going to draw the approximation to a normal distribution. If I said, well, Z is less than A is 87.7%, I've got to put A roughly in the right area. So this axis, because it's standard normal, 0 and 1, okay, so you wouldn't have to label this if you're doing it, but we know it's a standard normal, therefore this axis is the Z axis, so we're looking for the Z value. So if you were to say Z is less than A, is 87.7%, where would you put A on this axis? I heard him. No, I can't.
Right at the end of the curve.
Right at the end. What? Which end?
The right.
The right-hand end. So we know it's 87%, so it's going to have to be one end or the other. But we know the 87% is less than A. So we'll put a line. That's A, and what we're saying is that area would be 87, or call it 0.877. So we've worked out there. So what we're trying to do is work out what this A value is. Right. Okay with that? So that's what we're trying to do. So if you were going to do it the other way round, you'd have a value for A, you'd have to work out lower bound, upper bound of whatever that value was, and you'd end up with 87.7%. But we're going to use our calculator for inverse norm. Does anyone remember where inverse norm is? I'm sure you've seen it. So distributions again. Inverse norm. Okay. What do you reckon? 0.877. We've got 0 and 1 there already. Paste. Enter. We get the answer 1.16. Okay. Now, of course, that only works that not only works. That's a rubbish thing to say. That value 1.16 relates to a standard normal where all the values are 0, 1, 2, 3. So if I said to you A is how many standard deviations from the mean, what would you tell me? Yeah. So because it's a standard normal, A is 1.16 times the standard deviation from the mean. Right? If you change the values for mean and standard deviation, right, obviously that value that comes out is going to be different. Right? Now, sticking with this question a minute, what if I were to ask you this? What the probability of Z being greater than, let's say, or equal to A, just to make it clear it's the same thing. Well, what would the answer be?
1.
So what is that? 0.1. Okay. Now, let's say I haven't done this red bit. I haven't done that bit. So let's pretend we've not done it. All right. So I've got the probability that Z is greater than A is 0.123. Alright? Would we get the same value of A? So if we put it into our calculator, we should still get 1.16, yeah? So can you do that on your calculator? Tell me what you get. Negative. Okay. So that puts it where, do you think? Pardon? To the left. It is actually here, isn't it? Because what have I worked out? What's the calculator actually worked out? Think about what you don't have to put into the calculator. Not even the equals to, but the... Yeah, there's no upper and lower bound, and there's also no way of saying less than or greater than, is there? How did it know I wanted less than, greater than? It doesn't ask me, it doesn't work it out. So can we think, if the answer that it's given me for A is down here, what has the calculator worked out? So this 0.123 is where? Less than A. So this is the region that it worked out for the 0.123. So that leads us to a conclusion, which is, what does the calculator do? Over to you. If there's no option to change something, if there's no option to put greater than or less than, but I need to do both in my exam questions, calculator doesn't give me the option to choose, okay? But it still does something. That means it only does one thing. That's why I can't change it. What does it do?
So always calculating less than?
Yeah. So it always calculates less than. So Z less than A. That's what it calculates. Right? So if you wanted to do a more than A, what do you have to do?
Subtract it from 1
Yeah.
and then do
Exactly. So, as just to put this, if I want to calculate from inverse normal, let's say I have this value of A, and I want to know this region here, the probability that Z is greater than A, right? And I tell you that that is 0.64, right? In your calculator, you have to do the inverse normal, okay, of what? The probability that Z is less than A, which would be 1 minus 0.64. So your calculator will work out this side, and then you have to do a little bit of maths to just figure out the other side, which is not hard. That's the one thing you must remember. Because obviously if you forget that, you can end up with a really very, very different result than what you want. Make sense? Any questions on that? No? No question. Okay.
Why did you is it if they are equals to A? Why did you shape that under A?
Because this is the bit the calculator will work out. That's what it did. Because what you did in your calculator, I'm pretty sure, when you ran the inverse normal, right? Just do inverse normal. When you did it for this, I said to you I wanted to know the 0.123. Yeah? So that's the area. So I've told you Z is greater than A is 0.123. And what I was hoping you would work out was this area here. Because we already know A, don't we? We'd already done it. It was 1.16. So I was expecting the same answer. It should have been, you know, these two go together, those two make the answer 1. So what I was getting at was the fact that, well, if you're trying to work out that, you've got to put the area in, alright? But in your calculator, it asks for the area, so you put 0.123, which is what you're given in the question. But nowhere on that screen does it say, is this a less than A or a greater than A? It doesn't say it. It just says what's the mean and standard deviation. So that's why the calculator is set to work out less than. So if I want to know A is greater than, and the probability, Z is greater than A, and the probability is 0.123, well, I have to actually not do this. I have to do 1 minus 0.123. Does this work, all right? Everyone tried? Save having to do an extra calculation and get it wrong. Let's try it. Paste. Yeah, it works. So there you go, 1 less calculation to do. So if it's a greater than, just do 1 minus what the value that they give you and sort it.